Hi and welcome back to PHP Security Pitfalls. In the previous video we had a look at system information leakage, and now we'll talk about a different kind of, leakage if you will, namely sensitive data exposure. Every now and again you get reports from sites being hacked and sensitive data being stolen. Now this data includes health records, passwords, social security numbers, personal data, credit cards, and the list goes on and on and on and on. And let's face it people, this kind of data theft is not limited to amateur applications. Now sensitive data exposure is a vast topic that could well justify an entire course of its own, but we'll just discuss some major pitfalls here. According to OWASP, the Open Web Application Security Project, the most common flaw is simply not encrypting sensitive data. Now before you start encrypting data, you should first have a good hard look at the data you are handling. Do users really need to send you those credit card numbers? And do you really need to store them inside of the database? Well, if not, then don't. Because data you don't have cannot be stolen. But then if you do have to store data like passwords, do not ever store it as plain text. If you are using a third-party library or a framework, check that it uses a strong encryption algorithm and proper sorting. Now, to identify what that means, let's first have a look at some weak solutions. Inside of our project, we'll just create a new folder called hashing. And inside of that, I'll just create an index.php file. Now this is the way your grandfather did it. He had a password, which would be a string. Let's say it would be secret, the worst password ever. And then he'd just hash that through an MD5 function. So he would do something like MD5 and pass in the password and just close it out with a semicolon. Now I'll just echo that to the string and see what that brings us. Now there's our MD5 password. Back in the days, MD5 was considered a strong cryptographic algorithm. Well, one of the good things about MD5 is that you could encrypt a string, but there was no function to decrypt it. But now, using MD5 or even SHA-1 is considered bad practice. Why? Well, for one, if a database with passwords is stolen, a hacker can easily crack those MD5 passwords using what is called a rainbow table. Now basically, a rainbow table contains pre-calculated hashes of all kinds of passwords. So that would be a bit like creating a rainbow variable and make it equal to a new array. And we'd have an index for MD5 secret, which would give us the password secret. Basically, a rainbow table is filled with millions and millions of these pre-calculated hashes. So yes, there would be an index for secret, and there would also be an index for welcome. And that would result in welcome. And then there would also be indexes for alternative spellings such as welcome, like this. And that would result in welcome. Creating a rainbow table is really not all that hard because people tend to be creatures of habit. Passwords tend to be made up of normal words like tree. And then, to make passwords harder to get, people will include capital letters, and these will almost always be at the beginning of the string. And they will also sort them with numbers, which tend to be at the end of the string. And then there are basic spelling alternatives like a 3 instead of an E, a 0 instead of an O, etc. Another reason MD5 is easily cracked is because it's a very fast hashing algorithm. You can check hundreds of millions MD5 hashes per second on a pretty average PC. You don't believe it? Well, let's take this password and run it through MD5. Now I'll just take this MD5 string here, copy it, and run it through an online decryptor service. I'll just paste the password in here, and just type in the CAPTCHA, and there we go. You see? Cracked. And I didn't even fast forward. Now please folks, don't try this at home, of course. So what kind of hashing is safe? Well, at the moment using bcrypt is considered to be rather safe. However, encrypting passwords is a complicated matter that you should not tamper with yourself. It would be best to use a well-renowned hashing library. And of course you can find some unpackaged. One of them is Password Compat by IRC Maxwell. This library is also used by Laravel. And another one is Zencrypt from the Zen framework. Okay, let's just for argument's sake bring in Password Compat. I'll just go over to our project, remove this, and then I'll just create a file called composer.json, like so. And inside we'll just create a JSON object. We'll just set require. Now that will be equal to another JSON object and we need to go over to packages and copy the proper reference to the library. I'll just paste that in here and Bob's your uncle. Now I'll just open up the terminal and just cd into my project directory. And once I'm there, I'll just run composer install, like so. Okay, well I don't seem to have a composer.json file in my folder root, and that's correct because I created it into my public HTML folder. So I'll just move that up, like so, and I'll try it again. And we're lucky that's a single array, so that'll go quite quickly. And there you go, we now have a vendor directory with ILC Maxwell password compat inside. So I'll just go back into index.php and let's just comment this out. And down here, I'll just require, I'll just have to traverse up one directory, go into vendor, and make sure I require autoload.php, like so. Okay, I'll just create a new password, and that will just be a random string. And then I'll create a variable called hash, and I'll just make that equal to password hash. Now my password will be the first parameter, and the algorithm will be the second parameter. And here we'll use password underscore default. Now this is the way it's done in PHP 5.5. And the compatibility library, which is what this is some sort of forward compatibility to that function. As you can see at the moment, the password default algorithm is equal to password underscore bcrypt, which is the current strongest algorithm supported. Now let's see what happens if we echo hash to the screen, go back to the browser and reload, and we're getting a huge error there. I seem to be looking inside of the wrong directory. You probably already saw that. Let's just traverse up one more folder like so, and that should work. And as you can see, there's our hash password. Now, if you store this inside of a database, make sure you have enough room to store all the characters so it won't be truncated. Okay, now this library also has a function to verify a hash. To see that in action, we'll just do a var dump. And then inside we'll run password verify. Make sure we pass in the password, and also make sure we pass in the current hash. Now, if all goes well, this should be equal to true. Let's try that. And indeed it is. Okay, so we'll just wrap these into paragraph tags like so. Now just to go back to the password hash function, as you can see, it also takes an array of options. And one of the options you can pass, let's just create that array here, is the option cost. Now by default this is set to 10. Now the cost compares to the number of rounds that the algorithm goes through. And you want to experiment with this number here. Try and set it to the highest value you can without sacrificing too much speed. Okay, we've talked about storing hash sensitive data. But then again, sensitive data is not only stored, it's also transferred. For instance, when a user buys something from your web shop or logs into your admin panel, eavesdroppers can listen into that traffic, and we don't want that. So, time to have a look at the connection as well. Does sensitive data pass to and from your application? Then do not send this data as plain text. If traffic is over normal HTTP, it can be intercepted and read. Okay, now how can we fight this? Well, make sure you encrypt the application's traffic by using SSL. You can identify SSL traffic by the preceding HTTPS, where the S stands for secure. Now make sure you use a trustworthy SSL certificate. Now, if you want to know more about SSL, Tuts Plus and NetTuts have some excellent tutorials that can help you on your way. In short, SSL is an encrypted data transfer. A web server that uses SSL needs a digital certificate to identify itself. Such a certificate is issued by a certificate authority that vouches for your server's identity. Now, when a visitor's browser requests your site over HTTPS, it tries and locate that certificate. If it does, it attempts to verify it through a certificate authority. And once that has happened, the transfer is in progress. Now there are only a few prerequisites to run SSL. 1. Your domain needs to have a unique IP address. 2. You need to buy and install a certificate. Now certificate providers have installation manuals available for all kinds of server configurations. Okay? Well, that's all for sensitive data exposure. Code safely, and I'll see you in the next video.